The next problem is an absolute value problem, so we're going to draw a V for our basic shape. The horizontal shift is inside the function with the x, which is x minus 6, so it's opposite of the sign you see, so it's going to be positive 6. The vertical shift is outside the function, so that's going to be 4, just as you see it. So 6 comma 4 is my vertex. The compress and stretch is the number out in front. In this case, it's negative 3. Notice it's a vertical stretch and compress. Because it's negative, it's also going to be reflecting, so it's going to be pointing upside down. Going back to my basic shape, normally I would go right one and up one and left one and up one to get my critical values. But because I have a compress and stretch that is different, then I'm going to actually change those values to be negative 3 instead of 1. So going to my vertex, I'm going to go right one, and instead of going up one like I normally do, I'm actually going to go down 1, 2, 3. And then left one, instead of going up one like I normally do, I go down 1, 2, 3. Because this is an absolute value, I make sure that I have two straight lines making a V shape, pointing downward. On my next problem, I have a square root, so the basic shape for a square root is kind of like a parabola on its side, but just half of it. My horizontal shift, that's inside the function with the x, opposite of what you think, so it's positive 1. The vertical shift is outside the function. So my vertex, put the horizontal shift and the vertical shift together, I get 1, 5. The compress and stretch is the number out in front of the function, which in this case is negative 1. Going back to the basic shape, normally I go right one and up one, but because I have a compress and stretch, that up one is going to be changed to a negative 1, which in this case will be down 1. So the vertex I'm going to plot at 1, 5 to get my one critical value, and you need to get this one critical value correct because there's only 2 points you have to have right. The one vertex here, and there's only one critical value, so you better make sure you have that one correct. So I'm going to go right one, and normally I would go up one, but in this case, because I have a compressive stretch of negative 1, I'm going to go down 1. Connect those points, and you have your graph. On the next problem, we have two functions, f of x equals x squared plus 5, and g of x equals 3x minus 1. And we are asked to find the following, f of g of x. So I'm going to do all of the f problems in red and all of the g problems in green, just to keep it separate for you a little bit. So if I'm trying to find f of g of x, I prefer writing f of g of x in this form. It helps me a little bit so that I can do f of, instead of g of x in blue, I'm going to change out the g of x for what the g of x is equal to, 3x minus 1. Okay, that's the easy step. Now here's the tricky one. I need to use the f function. Now the f function says x squared plus 5, but I have to come in and erase the x. And instead of x, I'm going to use whatever's inside the parentheses. In this case, 3x minus 1. So the function f of x equals x squared plus 5. The x in that function gets replaced with 3x minus 1. Now that right there is the hard step. After this, the rest of it is just a bunch of distributing combined like terms. I have 3x minus 1 times itself 3x minus 1. So we have 9x squared minus 3x plus 1 plus 5. Don't forget to keep bringing that plus 5 down. I know some students will spend a lot of time getting the 3x minus 1 squared part correct, but then they'll just drop the plus 5, thinking that they'll just add it at the end, and then they accidentally don't, and then the rest of the problem's wrong. And in fact, the next problem is also wrong because the next problem might depend on this problem. So this is the answer for number 11. Now, notice number 12 and number 11 are very similar. Instead of f of g of x, in this case I'm doing f of g of some number, which in this case is negative 3. So there's two methods I can do here. One method is just use my answer from number 11 f of g of x is equal to 9x squared minus 6x plus 6. And if I'm trying to find f of g of negative 3, all I have to do is plug in negative 3 every time I see an x into the answer that I just got from my last problem. So we have 9 times negative 3 squared minus 6 times negative 3 minus 6. So let's just go ahead and evaluate that. So PEMDAS says I do my exponents before any multiplying. Now I can go back through and multiply. So we have 81, negative 6 times negative 3, that's plus 18. So I have 99 plus 6, or 105. So therefore, f of g of negative 3 is equal to 105. Okay, now that would be totally done. I don't have to do any more. But if you want, you could do another method. The other method is also very helpful. And if you forgot how to do number 11, well, if you don't know how to do number 11, you're never going to get number 12 using the method that I just showed you, because you had to use the answer to 11 to get 12, which means if you get 11 wrong, you might also then get 12 wrong because you're using the wrong answer. Okay, so here's a different method that doesn't require you to get number 11 first before you can get the answer to number 12. So if I'm trying to find f of g of negative 3, well, what I'm going to do is I'm just going to try to find g of negative 3 first using the g function. So we have 3 times x minus 1, and who's x? Well, negative 3. So that gets me negative 9 minus 1. So therefore, g of negative 3 is negative 10. So I can go and plug that back into my function. If I'm trying to find f of g of negative 3, well, all I have to do is find f of negative 10, because I know g of negative 3 is negative 10. So to find f of negative 10, all I have to do is plug negative 10 into the function. X squared plus 5, which is 100 plus 5, and look at that. F of g of x is 105. Excuse me, f of g of negative 3 is 105. So both answers came out the same, 105. So do I care which way you do it? No, I don't really care. Just as long as you're getting 105 and showing your work, that should be fine. Now, because we did it both ways, what we really did here is we checked to make sure we did number 11 correctly. I know, because I did it both ways, that I didn't make a mistake on number 11 because I got the same answer. On our next problem, it says use composition of functions to show that the following functions are inverses of each other. Okay, now if you read the way I wrote that problem, use composition to show that they are inverses. Because of the verb usage that I used, the answer is yes, they're inverses, okay? I'm telling you they are. I'm asking you to show me. Again, I'm going to use colors to help you out here. So I'm going to do F in blue and G in red, just to make sure. So the definition of inverses says that if you find f of g of x, and the two functions are inverses, at the end we should get an answer of x. Similarly, if I find g of f of x, and I evaluate that at the end, I should get x. That's what I'm hoping for, okay? So what I need to do is I need to be the one to show the work. So I have to do these two independent of each other. So I have f of g of x. My g of x happens to be x minus 4 over 3. I'm taking that g of x and I'm plugging it into the f function. Now the f function says 3x plus 4. 3x plus 4. But what I'm going to do is I'm going to come in and erase that x and replace x with whatever's inside my parentheses for the f function, which in this case is 3x minus 4 over 3. So now I have f of g of x in terms of x. Notice that in this case I have a multiply by 3 and a divide by 3, so those divide out, and I get x minus 4 plus 4, and then minus 4 plus 4 adds 0, so I'm only getting x. Yay, that's what I was hoping to have happen. If I plug x into g and then I take that answer and plug it into f, I should get itself back because f and g's should, because they're inverses, are undoing each other. So whatever the first function does, the second one undoes it, and all you're left with is the original x from the problem. All right, now I can't prove that that works until I do it backwards. So now I have to find g of f of x. So my f of x is 3x plus 4. I'm trying to find the g of that function. So the g of f of x, the g function says x minus 4 over 3. But I can't just use x. I have to use whatever's in the parentheses. So I'm going to erase the x and replace that with whatever's in the parentheses, in this case 3x plus 4. Alright, so in this case, because this bar goes all the way across, I can't do the dividing first here. You make sure you are simplifying correctly in the correct order. So in this case, because there's a bar here, I can't divide the 3's, but look, the 4 and the minus 4 on the same level, they can add to 0. Make sure you're doing it in the correct order. And then we have 3x over 3, and now the 3's are isolated and they can divide out to 1, which leaves me with just x. Yay! I've done what I wanted to do. I was looking for x and I got it. So therefore you need to write a statement at the end. So therefore f and g are inverses. I'm looking for some sort of statement at the end to make sure you know what you're doing. You're not just copying what you saw me do in the review video, okay? So you have f of g of x, make sure it's x. G of f of x, make sure it's equal to x, and then tell me what that tells you. The answer is f and g are inverses.